All right, folks, we're going to be talking about spheres for the first time today. Okay, so a sphere is just a three-dimensional circle, and since we haven't talked about it before, we get to look at both the surface area and the volume. Okay, so your formulas here are set up for you as 4 pi r squared. Okay, pi r squared comes from the area of a circle, we know. And then the volume formula, it's 4/3, and then it's pi r cubed. Okay, so pay extra attention here. The radius goes to the third power, just like our label with volume in general. Okay, so the nice thing about working with spheres is you'll notice the formula only requires one variable, and that is the radius r. So on number 1, we have the radius given to us as 5. So all we have to do for these formulas is just plug in. So surface area equals 4 pi r squared. That looks like 4 times pi times the radius 5 squared. Just like we did with all of those other shapes with pi in it, we leave that out to last. So it's 4 times 5 squared is 25. And we get 100 pi. So that's the number. Then surface area is always units squared, so we've got meters squared here. All right. Then, if we want the decimal version of that, we just multiply by pi to get 314.2 meters squared. Volume then, we're taking 4/3 pi r cubed. This time our 5 gets raised to the third power. Okay, we can do this all in one go with our calculator. So we'll take 4 divided by 3 times 5 to the third power. Okay, the third you need to use this arrow up here for. Okay, your calculator may not actually put that number in the exponent, but as long as you see that it typed in that value, you're okay. Now you'll notice this answer looks a little bit strange because we've got that repeating decimal. Okay, you can write it as 166.6 with the bar over it, pi meters cubed, or if you prefer, you can change this to a fraction. On these calculators, it's math and then enter twice. A lot of times on your other calculators, you will see an F arrow D fraction to decimal button, and you can click that. So you can also have 500 over 3 pi meters squared. They're both the same, okay, so I don't care which version you use. Then we multiply that by pi to get our decimal version, and we've got 523.6. All right, looking at the second one. Again, all we need for these formulas is the radius. Okay, we're given the radius here is 6. So surface area is 4 pi r squared. That looks like 4 pi times 6 squared. If you want to go ahead and call that 36, you can, but we're taking 4 times 6 squared. 144. Pi goes on the end. Label for area is always squared, so we've got feet squared. Multiply that by pi and we'll get our decimal. 452.4 feet squared. Volume, we've got that weird fraction in front, 4/3. And then pi times our radius cubed. So 4/3 pi times the number 6 cubed. Okay, so again, type this in with me here. 4 divided by 3, then times 6, use this little up button, the caret, to the third power. And this one, it ended up coming out nice. So we just write 288 pi and then feet cubed. If for any reason you're getting different decimal values when you're typing these in, or different numbers in general, please come see me, let me know, and we can figure out what's going on with your calculator or what you're typing in incorrectly. Okay, then we multiply that by pi to get 904.8 feet cubed for the approximate. All right. One more time together, we've got surface area, 4 pi r squared. R is given to us in this case. Okay, our r is 3. So 4 times pi times 3 squared. So 4 times 9, okay, 3 squared is 9, 36 pi inches squared. And our calculator times pi for the decimal. 113. You'll notice there's a 0, but that 9 makes it go up to 1 inches squared. Volume, 4/3 pi r cubed. So 4 divided by 3 times pi times 3 to the 3rd power. Okay, so we're taking 4 divided by 3 times 3 to the 3rd. And we get 36 inches cubed. Just like with some of our other shapes, it is possible for our surface area and our volume to look the same. They did in this case, which means our decimal has to be the same as well. So I'll just drag it down. Your label is different. Okay, so they're different sizes really when we think about them geometrically, but their number value looks the same. All right, what I want you to do right now is pause the video and take care of number 4 for me. When you're done, you can hit play and check your answers. All right, you will notice on here, okay, surface area just 16 pi centimeters squared, but for volume, I wrote 2 different answers. Okay, remember, when you have a decimal, you can write it with the repeating decimal with that bar on top, or you can change it to a fraction. It is your choice on those. Okay, both of those are exact answers. You just can't use 0.7. You can't round there. The whole point of leaving pi in the answer is so that it's exact. We're not allowed to round. Putting that bar on top means it's exact. They know that we didn't round. It's really a bunch of 6s after that 10. Okay. Now what you'll notice on the next couple is we have some hemispheres. Okay, this is called a hemisphere. And what I want you to do is write the surface area and volume formula for these. Okay, we're going to talk about a hemisphere in terms of both of these things. Okay, so just work with me here. Surface area for a whole sphere is equal to 4 pi r squared. Okay, but this whole thing is only half of a regular sphere. Okay, we don't see this missing piece below. So all we have to do to get the formula for surface area is divide this thing in 2. All right, but there's one little detail that we have to add in. Remember from your formulas before that when we're dealing with surface area, it's always going to be lateral area plus some number of bases. Well, this 2 pi r squared is our lateral area. We still have to talk about that bottom part that was not on the outside of our original sphere. Okay, that bottom portion is a circle, so we add area of the base of a circle, pi r squared. Okay, so on your yellow sheet, you'll notice that this 2 and this 1 was put together, and the surface area of your hemisphere was just written as 3 pi r squared. Okay, so we can use that just as long as we're including the base. Okay, remember some word problems that we'll be dealing with, the base may or may not be included. Okay, so really, we're taking half of the whole sphere and then adding the bottom pi r squared. Okay, so that's where it really comes from. So up top, I want you to write surface area of a hemisphere equals 2 pi r squared plus pi r squared. Okay, this is your lateral area plus the base. All right. The nice thing about volume is we don't have to worry about a lot of that. Okay. volume formula for a whole sphere is 4 thirds pi r cubed, okay, but I want to divide this by 2. Now because we have a fraction in here, it's kind of hard to write that as divided by 2, so instead I want to think about it as times 1/2, and when we take 1/2 times 4 thirds, we get this weird looking decimal, but ends up being just 2 thirds. Okay, here's why. This 4 and this 2, we can say 4 divided by 2 is just 2. So that's where the 2 and the 2 thirds comes from. Okay, so for the volume formula, we'll just say it's 2 thirds pi r cubed. Okay, so up top again, we'll write volume for this hemisphere equals 2 thirds pi r cubed. Okay. Now that we have those, let's go ahead and find each. So surface area. Okay, we have to do 2 pi r squared and then plus pi r squared. R here is given to us as 5, so we can just plug stuff in. 2 pi times 5 squared, and then plus pi times 5 squared again. We've got 2 times 5 squared, which is 50 pi. And then 5 squared is 25. It's 25 pi. And lastly, we're taking 50 plus 25 for 75 pi. Surface area is 75 pi meters squared. Okay. Now again, we said this combines to be 3 pi r squared. Just to show you it's the same thing here. If we take 3 times pi times 5 squared, we get 3 times 5 squared is 75 pi. Okay, same answer. The only reason I'm having you split it up this way is because when we're talking about this surface area, we like to set it up lateral area on the base because sometimes our base doesn't count when we deal with compound problems. Okay, so we've got that taken care of. Now let's do the volume, which should be a little bit easier here. Okay, it's 2 thirds pi r cubed, and that looks like 2 thirds pi, radius was 5, to the 3rd power. Okay, so again, we may have fractions in our answer, but that's okay if that happens. In this case, it did, so we can write that as 83.3 with a bar over it, pi meters cubed, or if you prefer, you can change it to a fraction and call it 250 over 3 pi meters cubed. Okay, both of them give the same decimal when we multiply by pi, and that's about 261.8 meters cubed. Okay, we'll go back up and grab this decimal, 75 times pi, and that's 235.6 meters squared. Okay. All right. On the next one, let's set it up how we usually do for surface area and volume. Okay, what I want you to do here is think of surface area as lateral area plus 1 base, like we do. Lateral area portion was our 2 pi r squared. Area of the base, our base is a circle, so it's pi r squared. And then we can end up putting those together as we simplify. So our radius in this case is 10. So we've got 2 pi times 10 squared. Okay, 10 squared is 100, times 2 is 200. If you need to type that in, you're absolutely welcome to. Over here we've got pi times 10 squared is 100 pi. and then we just have to add those together for our total surface area. 200 pi plus 100 pi is 300 pi yards squared. To get our decimal, we'll take 300 times pi, and it's about 942.5 yards squared. Okay. Volume, we just have 2/3 pi r cubed, so that's 2/3 pi times 10 cubed. So 2 divided by 3 times 10 to that third power is, again, you have a couple options for writing this, 666.6 repeating with pi yards cubed, or you can change it to a fraction and call that 2,000 over 3 pi yards cubed. Decimal stays the same, so we're going to multiply by pi to get about 2,094.4 yards cubed. Okay, so that's how we want to set them up for the hemisphere. Okay, just like we've been doing surface area of everything else, lateral area plus some number of bases. We've got one base when we split a sphere in half. Okay. Now let's do some word problems here. Combine some of this stuff together. It says, Farmer Joe enjoys bird watching, so he is building a bird bath that's drawn below out of concrete. Okay, so this whole thing is built out of concrete. After he is done forming it, he will paint it. Okay, so our first question is to decide how much concrete will he need to form the bird bath. Well, when we're talking about concrete, okay, that's something that's filling the shape. Okay, so it's on the inside. And with a bird bath, this hemisphere here, okay, that is the bowl that the bird is bathing in. That's where the water goes. So that bowl is actually empty. All right. So normally when we're dealing with our compound shapes, we have to do Normally with our compound shapes, we're doing one on top of the other. This time, there's one shape inside of the other. Because of that, we are going to do subtraction instead of addition here. So here's how I want you to set this up. We're going to do a volume since it says fill. Okay, so we're going to do the volume of the big one. And we're going to do volume of the small one. And then we'll subtract them. So the big shape is a cylinder. Cylinder is area of the base times the height for our formula. All right. Area of the cylinder, okay, area of the base of the cylinder, it's a circle, so it's pi r squared. That looks like pi times our radius squared. Our radius is just 1 here. Well, 1 times 1 is still 1. So we've got 1 pi for the area of the base. Then the height of this cylinder is 3. Okay. The volume of the small shape, that's our hemisphere we were just talking about. So that's 2/3 pi r cubed. Okay, and that looks like 2/3 pi times our radius, again, is 1 cubed. Now, if 1 times 1 was 1, 1 times 1 times 1 is still 1. So this just looks like 2/3 pi here. Okay, so then how much concrete is needed to form the bird bath? We just have to take 1 pi minus 2/3 pi. Okay, so we'll subtract them. So 1 pi minus 2/3 pi. Okay, so 1 minus 2/3. Okay, so we can write this at 0.3 with a bar pi, and then feet cubed, or we can say 1/3 pi feet cubed. Okay, as a decimal, which is more useful for word problems in general, that's about 1.0 feet cubed. Alright, for surface area, we're going to paint, okay, we got to think about what we would paint here. Okay, so we'll paint the outside of the cylinder and then the inside of the hemisphere. So we want the lateral area of both of those shapes, lateral area of the cylinder and lateral area of the hemisphere. Okay, so on our cheat sheet, the cylinder lateral area looks like 2 pi RH. Okay, so 2 times pi, our radius is 1. Our height of the cylinder is 3. Okay, so I've got 6 pi here. We'll use that. Then hemisphere. Okay, since we only want the lateral area, we just want the 2 pi r squared. Okay, so that looks like 2 pi times 1 squared. Again, 1 squared is just 1. Multiply it by 2, and we've got 2 pi here. All right. So now when we put it all together, surface area, we want to paint both of these, so we have to add them. We've got 6 pi plus 2 pi is 8 pi feet squared. Okay, that's approximately, again, because word problems, it's more useful to think about it in terms of the decimal, is 25.1 feet squared that we're going to have to paint here. Alright, now we're going to go to the back side here and talk about a cone and a hemisphere. Okay, this shape represents an ice cream cone. It says the ice cream store sells soft serve ice cream cones as diagram below. On a hot day, they sell about 200, so we're going to use that here in a little bit. But first of all, just ask how much ice cream is in one cone. This N tells you volume, and we want to do the volume of each shape. Since they're stacked on top of each other, we'll add them together. Okay, so the first one, we've got volume of the hemisphere. That's our 2/3 pi r cubed. Okay, so 2/3 pi. Our radius here in the picture is 3 cubed. Okay, so we'll take 2/3 times 3 to the 3rd power. Gives you 18, and then that pi on the end. Okay, so we'll use that. Then we have to do the volume of the cone. Okay, this one, since we've got a point on our shape, our formula is 1/3 area of the base times the height. Okay, so let's talk about what that area of the base would look like. Okay, so big B equals, since it's a circle, we've got pi r squared. That's pi times our radius, 3 squared. 3 squared is 9, so 9 pi here. Alright, and then our h that we need is up through the cone here, 10. So putting it all together, we've got 1/3. Area of the base was 9 pi. Then the height is 10. Okay, so we've got 1/3 times 9 times 10, which is 30 pi. Alright, so adding those together, okay, we get 48 pi centimeters cubed. But again, we want the decimal version of this, and we'll continue just using that for the rest of this problem. It's about 150.8 centimeters cubed of ice cream in that one cone. Okay. For the second part, it says how much ice cream is used when all cones are sold, so all 200. So if this is the number for one cone, we have to take that and multiply it by 200 cones. Okay, so 150.8 times 200. So that gives us 30,160 centimeters cubed. Last question here. It says 1 gallon contains 3,750 cubic centimeters. We want to know how many gallons of ice cream they will need to serve these 200 ice cream cones. Okay? A lot of times when we're dealing with numbers that aren't our basic conversions, feet, inches, things like that, it's useful to set up a proportion in order to decide whether we need to multiply by that 3,750 or divide by it. Okay, so here's what we're going to do. 1 gallon is the same as 3,750 centimeters cubed, and then we'll set it equal to, it says how many gallons, so X is our gallons, that's on top for this proportion. And then on the bottom, we're going to use our answer from before, that 30,160. Because our label for that was our centimeters cubed, like we have over here. Then we'll cross multiply. So we'll see 3,750x equals 1 times that is itself. That tells us we need to divide by that 3,750. So x here is about 8 point, now this notice goes to 0, but if you need 0.4, if you need that extra bit of ice cream, 8 gallons wouldn't be enough. Okay, remember when we're talking about gallons, we need to round up to the next whole number. Okay, so we would actually need 9 gallons if we wanted to serve all 200 cones and not leave anybody short. Okay? If you have any questions while you're going through working on your homework, please stop in to see me.